All right, let's spend a few minutes talking about solving two-step inequalities. This is going to be very similar to solving two-step equations. And really the secret to that is figuring out what order to do the steps in to make it easiest for yourself. So we'll take a look at that, and then we'll look at how to use these in the real world. So first, let's talk about our strategies here. So remember, what we want with solving two-step inequalities, just like with an equation, is we want to get the variable by itself by performing the opposite operations. So addition and subtraction are opposite of one another, and so are multiplication and division. And we want to pick an order that makes sense, that makes it easier for us to do those operations, to get that variable by itself. And then, of course, there's this gotcha with inequalities. If you multiply or divide by a negative, you have to switch the direction of the inequality. And then it's always good to check your answer to make sure that you've got something that makes sense. Okay, let's do an example here. So here we have an inequality of 2a minus 3 is greater than or equal to 7. I've accidentally shown the next step here. That's great. We want to get that a by itself. And so there's two things that are bugging us, the 2 and the minus 3. We could divide everything by 2, but then we'd be dealing with a minus 3 halves and a 7 halves, and most people would prefer to work just with integers instead of with fractions like that. So probably the easier step to take first would be to get rid of this 3. It's being subtracted from the a term, and so we want to add it, do the opposite operation, just like we said is our strategy up here. So if we add 3 to both sides, on the left side we'll have minus 3 plus 3. That'll go away. That'll be just 0, and we'll just have 2a. And on the right-hand side, we'll have 7 plus 3, which is 10. So let's go ahead and write that. So now we have 2a is greater than or equal to 10. The only thing standing in our way of that a by itself is that 2. What's it doing to the a? It's multiplying, right? So we want to divide both sides by 2, do the opposite operation. And so the 2 divided by 2, and this is important to understand, oftentimes we say these cancel out. That's true. What we really mean is that 2 divided by 2 is 1. And so we just have 1a on the left-hand side. We don't need to write the 1 in front of an a or any variable. So they cancel out and we'll just have a left. That's what we mean when we say cancel out. And then on the right-hand side, 10 divided by 2, of course, is 5. So we get an answer here, a is greater than or equal to 5. Okay, now let's make sure and check this answer. Let's check a variable that is greater than or equal to 5. I'm sorry, a value. Let's check 6. So if we say 2 times 6, that's 12, minus 3 is 9. Is that greater than or equal to 7? Yes, it is. You could check lots of other values with inequalities to make sure. You could say, what if a was equal 5? Well, 2 times 5 is 10 minus 3. That would equal 7. So it is still greater than or equal to 7. So that's also true. If you tried a value that's not greater than or equal to 5, let's try 0. So if you put 0 in for a here, 2 times 0 is 0. Minus 3, that's negative 3. Is negative 3 greater than or equal to 7? No, it's not. So as long as we have values that are greater than or equal to 5, looks like that's the correct answer. Okay, let's do another example here. Here we have negative 6 times the quantity p plus 2 is less than or equal to negative 30. Now here we have two things that stand in our way of having p by itself. There's the negative 6 that's multiplying by a whole quantity, and then there's the plus 2. We could conceivably try to get rid of that plus 2, but we'd first have to distribute the 6 in there. So probably it's best to get rid of this negative 6. It's multiplying, so we do the opposite. We're going to go ahead and divide. So negative 6's will cancel, like we explained earlier. And on the left-hand side, you'll just have p plus 2. And then on the right-hand side, you'll have negative 30 divided by negative 6. You can probably do that in your head from times tables. 30 divided by 6 is 5. It's a negative divided by a negative, so it's going to be a positive. So it'll be positive 5. But watch the tricky thing here. So we'll have p plus 2 on the left-hand side and positive 5 on the right-hand side. But look what we did to that inequality. Because we divided by a negative 6, anytime you multiply or divide by a negative number, that's the gotcha up here. With an inequality, you have to switch the inequality signs. We've taken it from a less than or equal to a greater than or equal to. Okay, now that we've done that, that 2 is still standing in our way of p by itself. It's being added to the p, so we want to subtract 2 from both sides. On the left-hand side, you'll just have p. On the right-hand side, you'll have 5 minus 2, which is 3. Again, we can check our answer. Let's take a value that is equal to 3, for instance. And we'll go ahead and put 3 plus 2 would be 5 times negative 6 would be negative 30. Is that less than or equal to negative 30? Yes, it is. So if we tried other values that are greater than or equal to 3, we would also find that they work in the inequality, so we can go ahead and say that that's the correct answer. Now, how are these things used in the real world? Let's look at an example. Lakeisha is a scientist who has invented a machine that lowers the temperature of any solution by 2 degrees each time you press a button on the machine. For an experiment, Lakeisha starts with a solution at 37 degrees and needs to lower its temperature below 15 degrees. Write and solve an inequality for the number of times Lakeisha needs to press the button. Okay. So what is it that we're looking for here? That's usually a good thing, is to identify what our unknown is. And it looks like it's the number of times Lakeisha needs to press the button. So let's create a variable n that's going to be the number of button pushes. And as with equations, you always want to look for starting values and ending values. So you can see from the description up here that she started at 37 degrees and she ended at 15 degrees, or she needs to be below 15 degrees, I should say. So our start value is 37. And our end has to be less than 15. And then we want to think about the rate of change. So how much does, each time there's a button push, each time there's an N, how much does the temperature change? Well, it changes by 2 degrees. So, and it actually goes down by 2, so our rate is negative 2. So now what we can do is we can put these different values together with the n into something that kind of tells the story of Lakeisha's situation here. So we can say we start with 37, we end up at less than 15, or we need to, and in between, each time there's a button push, we lose 2 degrees. So do you see that if we put 1 in for n, that would take the 37 down by just 2 degrees. Put 2 in for n, 2 times negative 2 is 4. That would take the 37 down by 4 degrees. So this inequality is a great capture of this situation here. We probably want to switch the order so that we have the variable term first, like we do in these examples over here. So if we rewrite this inequality, we have negative 2n plus 37 is less than 15. Now we have something that looks very similar to what we've solved on the left-hand side of the screen here. So let's go ahead and solve that. We could divide by the negative 2, but then we'd be dealing with some fractions. So probably better to do what? Yeah, subtract 37 from both sides to get rid of that 37. On the left-hand side, then we'd just be left with negative 2n. And on the right-hand side, 15 minus 37 is negative 22. So it looks like that. Now, we need to get rid of that negative 2. What's it doing to the n? Right? It's multiplying. So we're going to do the opposite and divide. When we divide, remember, we're going to have to switch the order, or the direction, I should say, of that inequality symbol. On the left-hand side, we'll just have n. On the right-hand side, negative 22 divided by negative 2 is going to be just 11. And notice how we switched the direction of the inequality symbol here from a less than to a greater than. Now, we can always go ahead and check that answer too, as long as, what we're saying here is, as long as Lakeisha pushes that button more than 11 times, not greater than or equal to, but more than, greater than 11 times, she's going to be okay. So let's try 12 and see if that works. So if we start with, we can go to our inequality right here as probably the easiest place to do it. Put 11, or let's put 12 in here. Negative 2 times 12 is negative 24 plus 37. So 37 minus 24 would be 13. Is that less than 15? Yes, it is. So that will work. So you can see that Lakeisha needs to push the button more than 11 times is the proper conclusion that we're making here. And that's how we use two-step inequalities in the real world.